Here we have a SAT math problem. Okay, let's go to the question. In the XY plane above, what is the measure in radians of angle AOB? So here we have angle AOB. We have to get the angle measure in radians. Okay, now what I'm going to do is I'm going to draw a perpendicular line from the point A to the x-axis over here. Okay, and also let me draw another perpendicular line from the point B to the x-axis. Let me draw it. Okay, so here since both of them are perpendicular lines to the x-axis, here we have a right angle, and also here we have a right angle, and also let me say this is point C, that is the point where the perpendicular line intersects x-axis C, and here let me assume this point as D. Let me mark it over here. Okay, so here the x-coordinate at the point B is -6 times square root of 2. So the value we have on the x-axis over here is -6 times square root of 2. When I consider the length of this line segment OD, so we have to take the same x value, but we have to consider it as positive because the length cannot be negative. So the length of this line segment OD is 6 times square root of 2. And here the y-coordinate at point B is 6 times square root of 2. That is on the y-axis over here, we have the value 6 times square root of 2. So that means that this length is 6 times square root of 2. Since this line segment BD is parallel to this one, so this BD also must have the same length, that is 6 times square root of 2. Okay, now let's consider this right triangle OBD. In this right triangle OBD, so two legs are equal, and also we know that OB is hypotenuse because it's opposite to right angle. So in this right triangle, the two legs are equal. In any right triangle, if two legs are equal in length, then it's a 45, 45, 90 special right triangle. So here we have 90 degree. So the angle measure over here has to be 45. The angle measure over here has to be 45, 45, 45, 90 triangle. Okay, so clearly this angle measure is 45, but our aim is to get the angle AOB in terms of radians. Since we have to get this angle measure AOB in terms of radians, instead of marking the two angle measures over here and here in degree measure, we can mark it as mark it in radians. That is 45 degree equals to pi over 4 radians. So here the angle measure is pi over 4 radians. Okay, now let's come to the right triangle OAC over here. In this right triangle OAC, let's consider the vertex A. The point vertex A is 6 square root of 3, 6. The x-coordinate is 6 times square root of 3. So the value we have on the x-axis over here, 6 times square root of 3. Clearly, the length of this side of the right triangle is 6 times square root of 3. And the y-coordinate is 6 over here. Clearly, the length of this side of the triangle AC is 6. Okay, now let's consider the right triangle OAC. OA is the hypotenuse because it's opposite to right angle, and these two sides AC and OC are the two legs. And when I consider the length of the leg OC, so that is 6 times square root of 3. That is the length of this leg AC is multiplied by square root of 3. In which type of right triangle this kind of thing will happen? Usually it will happen in a 30, 60, 90 special right triangle. Because in 30, 60, 90 special right triangle, we will consider the shortest leg as X. And to get the next longer leg, that is OC, what we will do is we will multiply the length of the shortest leg by square root of 3. Then the length of this leg will be x times square root of 3. So the same thing we have over here and here. So here we have x, instead of x we have 6, and here we have x times square root of 3. So instead of x times square root of 3, we have 6 square root of 3. So here at the place of x, we have 6. So clearly OAC is a 30, 60, 90 special right triangle, and here the shortest leg should be considered as AC. So because so this is the leg which is having the length x, and this is the leg which is having x times square root of 3. So the leg which is having the length x should be considered as the shortest leg. So AC is the shortest leg. Always the shortest leg will be opposite to 30 degree. 30 degrees means in radians it has to be pi over 6. So the angle measured over here is pi over 6. Now let me assume the angle over here as a theta. That is, theta represents angle AOB. That's what we have to find according to the question. So now my aim is to get the value of theta as in terms of radians. Okay, now consider the three angles over here, pi over 4, theta and pi over 6. These three angles together form a straight angle. We know that angle on a straight line always measures 180 degrees or pi radians. Since these three angles together form a straight angle, these three angles must add up to pi radians. Okay, let me write the stuff over here. That is pi over 4, positive theta, positive pi over 6 equals to pi radians. Now we have to solve for theta in this equation. For that we have to combine this one and this one. Let me write them together. That is theta positive pi over 4 positive pi over 6 equals to pi. Okay, now to add these two fractions, we need to get the same denominator. For that, we have to get the least common denominator of this 4 and 6, that is 12. So for that, we have to multiply the numerator and denominator over here by 3. Then I'm getting 3 pi over 12. And here I have to multiply the numerator and denominator by 2. Then I'm getting 2 pi over 12 equals to pi. Okay, now I get the same denominator for both the fractions. We can take 12 as a common denominator. We have to add the numerators 3 pi, positive 2 pi. When I do so, I am getting 5 pi equals to pi. Since my aim is to solve for theta, we have to get rid of this one. For that, we have to subtract 5 pi over 12 from both sides of this equation. Let me do it. So when I do so, this positive value, negative value will cancel out. Then the resulting equation is theta equals to pi negative 5 pi over 12. Now we have to simplify this one. Let me assume there is a denominator 1 for this pi over here. Now to get the same denominator for both the fractions, we have to multiply the numerator and denominator over here by 12. Okay, let me do it over here. When I multiply the numerator and denominator by 12, I am getting 12 pi over 12 negative 5 pi over 12. Okay, now we have 12 as a common denominator. We can take 12 as a common denominator. We have to subtract the two numerators because we have negative sign over here. That is 12 pi negative 5 pi. Then I'm getting theta equals to 12 pi negative 5 pi 7 pi over 12. Now I got the angle measure theta in terms of radians, that is 7 pi over 12. Actually theta represents angle AOB. So the measure of angle AOB is 7 pi over 12 radians. We find this 7 pi over 12 in answer choice D. The correct answer choice for this question is D.